Okay, now here, I hope now you have the concept of correlation with the help of the scatter diagram. It's very much clear to you how we analyze the type of correlation between the two quantities after having a look to the scattered plot of the set of data. I think now it is very much clear to you. Now move ahead and see, before approaching to the line of the best fit and understanding the regression bands. Before that, just try to have a look on in the past preliminary of your mathematics, establishing the linear equations by looking the straight line and maintaining the slope, how to calculate the slope and how to find out the y-intercept. I'm just telling you this because it is you are studying this whole stuff after a sufficient gap. So there's a reason why I feel that it is necessary to put down an explanation in this regard. So here you see I have just tried to maintain a very easy going graph that deals with these set of points. Now I have just plotted these points over here, and I just got a straight line passing through the origin over here, you can see. So here, if I just ask you to just calculate the slope of this line, what you are going to do, and one thing more, that another name of slope is gradient, okay? And you can see here that I have just discussed in the previous lecture that if your line is going uphill to right, it is representing a positive slope. So how the slope comes positive and how we calculate that, just see this thing, that if I say that I am moving, this point has moved from this position to this position, so it has covered this much distance, okay? And this is a slanting line, okay? It is a line having a certain slope. It is a slanting line. It's not a straight line parallel to the y-axis or parallel to the x-axis. It is not like that. It is a slanting line, so it is having a slope. So how we calculate the slope? So you see here that this point has basically, it has moved over here, and then it moves upwards like this. Okay, so first of all it moves over here, or I must say it run over here, and then it rises over here, and then it approaches at this position. Okay, that is lying at 2. So you see here, before it hasn't reached this point directly, it has actually selected a track that it runs over here first, and then it rises up till here. So what is the distance from this point to this point, means the vertical distance, and what is the horizontal distance from this point to this point? So you can see that if, for example, I say that from the origin to the point 2, I just say that this whole distance from here to here is your x2. Okay, and this whole distance from here to point 1, I just say that this is your x1. Okay, and I need the distance from here to here, which is parallel to this length. Okay, it is parallel to this length. How you're going to obtain this length? You see, if you just subtract out of this big line this small portion out, you're going to get this portion left. Okay, so actually you are subtracting x1 from x2 in order to get this length. Okay, in the same manner, you need the length of this line as well, this line segment. You can see from this point 2 to the origin is over here, the distance is y2. Okay, I'm just using notations here, and from origin to the point 1, this length is y1. Okay, and you need actually this much length, which is right equal to this much length. Okay, so how you're going to obtain this line? If you just subtract this portion, this much portion from this whole portion from here to here, you're going to get this much portion left. So actually this length is obtained by subtracting y1 from your y2. Okay, so that's how you have obtained. So you see here, this is basically a right triangle. You can see that this is a right triangle. Okay, and in the right triangle you apply your Pythagoras theorem, because Pythagoras theorem is something that is applied only in the right triangle, and it is equals to what? Hypotenuse square equals to your base square plus perpendicular square. This is the Pythagoras theorem, all right? So you can obtain this length either with the help of this method. You know the length of your base, you know the length of your perpendicular. This is the baseline, this is the perpendicular line. You have just calculated the length of this base and this perpendicular. Just substitute those values here, get the squares, then add them and take the square root, and you are going to get this length of hypotenuse. One method is this. Another method is this. Just take out the ratio of these two lengths. You are going to get the length of this slanting line. So you see, we just select the ratio method. That's rather easier because this is something that you study in your pre-calculus. So okay, so slope is the ratio of your rise over run. Okay, so over here I have just written that. So instead of using Pythagoras theorem, the rather easier method is to use the slope method. So we have just done that, and the rise length was this, the run length was this. We have just obtained that. Okay, now this is the general formula of calculating the slope that is also represented by m. Okay, now over here you can select any two points out of this whole set. So I have just selected these 2 points, this point 1 and this is my point 2, and this is my x1 y1 and this is my x2 y2. Okay, so I have just substituted these particular x and y values in the formula over here, you can see, and I just solved it and I just got the answer 1. Okay, and you know that 1 is greater than 0. This is a positive value. So if okay, so here after solving you come to know that the slope of this line representing x1 y1 and x2 y2 points, we have substituted over here and we just got the slope of this line. And once this line was uphill to right, and as we have already seen just after seeing the nature of the line that it is going to hold a positive slope, we solved it and we come to know that yes, the value that we are having at the slope is positive, it is greater than 0. So if it is coming 1, then this is said to be the least upper bound of your correlation coefficient value. And if you're having one answer, once you are determining the value of the coefficient of the correlation, it comes if it comes 1, then you will say that this the relationship or the correlation between the two quantities is highly positive and is explaining you a highly positive direct correlation. So if the coefficient of the correlation, that is if you are dealing with a sample data and you are asked to calculate the correlation between the two quantities which are explained in the data of a sample given to you, then the coefficient of the correlation for a sample of data is represented by small r. Okay, and if you are given a data comprising the whole population of any place and you are asked to find out the correlation between the two quantities that you are discussing over there, then over there the coefficient of the correlation relating to the population is represented by this notation. Also people use p there, but we use here rho. Okay, this is a Greek notation, rho, we call it rho. Okay, so that's it. Once over here we are getting the slope value positive 1, so we are having a very strong positive direct correlation. So that's how we establish, we just calculate the value of the slope after looking at the set of points present or lying on the line. Now if I ask you just establish the equation of this straight line and how you're going to do it, so you can see here we have just calculated the value of our m, that is slope, and another thing that is required here is the y-intercept, because you know that the general formula of your straight line or linear line is y equals to mx plus c. Okay, here m is the slope and c is the y-intercept. Now there comes the concept what exactly a y-intercept is for the new learners. So you see y-intercept is actually the point that is so obtained, the line that touches the y-axis that point where the line touches the y-axis is said to be the y-intercept. Okay, and here in this case, this straight line is touching the y-axis at the origin, that is at point 0. Okay, so here the value of c is 0. Okay, so in this case, once when I'm going to substitute the corresponding values of my slope and my y-intercept, I come to know that my equation of this straight line is y is equals to x. Okay, and now in the same way, let's discuss another case that deals with a negative slope. And over here I am having a line which is so drawn downhill to right. Okay, downhill to right. So you can see that I have just maintained here 3 points, and then I just produced or extended my line onwards on either sides, which are cutting the y-axis and the x-axis respectively. So you can see here that this line is cutting your y-axis at point 6. So 6 is my c. Okay, my y-intercept is c here. And now let us calculate the value of our slope. So you can select any 2 points you want. So once the points are starting from here, okay, this is the first point, this is second, this is third. Don't go like this. Okay, the progression is happening in this way, in this order. Okay, in this direction, not in this direction. Okay, you're plotting the points from the beginning. Okay, and they are behaving downhill to right, they're moving or they're progressing downhill to right. So that's how you start counting your points. So this is your first point, this is your second, this is your third point. Now you can select any 2 points you want in a consecutive way. So I just select, for example, I just select this point as my x1, y1, and this point as my x2, y2. Alright, so this is it. And now I'm going to substitute these points in my slope formula, and I just found that the value of my slope is -1, so it is less than 0, so this is negative value. So you can see here, if your slope is coming negative, then the subjective correlation between the two quantities is inverse. Okay, so inverse correlation is there, so it is a negative inverse correlation. So you see the value of the slope really helps us a lot in determining the type of correlation. Is it a direct correlation or inverse correlation? As well as the weakness and strongness of the correlation is depend that you call degree of correlation. That's what we that is something that we analyze after seeing the how much the points are scattered and how much they are concentrated. On that basis, we are going to say that this is a strong correlation and this is a weak correlation. Okay. As far as the direct and inverse correlation is concerned, this is something that we assign after seeing the value of the slope of the line of the best fit that we are going to draw. So the best fit we are going to discuss right after this, after dealing this graph. Now let us maintain the equation of this line. Okay, we have just calculated the value of the slope, which is -1. The value of the c is 6. So just write over here that y is equals to mx plus c there. So this time my y is minus 1x plus 6. Okay, so the value of so the equation of this line is this. Okay, that's it. So now one thing more, that as I've just told you that we have just learned up till now how to maintain the equation, how to maintain the how to come to know the nature of the correlation, either it is direct or either it is inverse, with the help of after analyzing the line, either it is moving uphill to right or downhill to right. On that basis, we just assign the degree of correlation and the directness and inverse correlation nature. So the direct and inverse correlation is determined after analyzing the slope. It is done. As far as the degree of correlation is concerned, that is something that we analyze after seeing the nature of the scattered plot. If it is very much scattered, if the points are extremely scattered, you will say that this is a weak correlation. It is representing a weak correlation between the two quantities that you have plotted on the plane. And if it is it is representing a very thin regression band, and it is representing a very concentrated band, the band of points, so you will say that it is representing a very strong correlation. This is something that we have assigned. We have just observed the degree of correlation only on the basis of on the basis of the scattered plot. So the question comes in mind: is there any numerical method of determining or of coming to know the nature or the degree of correlation? So is there any mathematical way, a calculation way, or quantitative way, I must say? So yes, there is. So once, if you want to come to know the degree of correlation, that whether the correlation is strong or weak, then for that purpose, numerically, you just solve the work, and for that purpose, you need a representation for the correlation that you call the correlation coefficient. Okay, and as I told you already, that the correlation coefficient, if you are dealing with the sample data, then it is represented by R, and the value of your R comes from lies within this range from -1 to +1. Okay, so if the value of your R after calculating is -1, then you will say that this is a very strong inverse correlation, because it is a negative correlation. And if your R value comes out to be +1, then you will say that this is a very strong positive correlation, representing that there is a direct proportionality between the two quantities. So -1 represents negative correlation, means a strong negative correlation represents the inverse proportionality between the two quantities, and a strong positive correlation, if it comes out to be 1, then it is representing strong positive correlation, representing that there is a strong direct correlation between the two quantities. If the value of correlation comes to be 0, if it comes to be 0 after solving, so in that case you will say that there is no relationship between the two quantities. If one quantity is increasing, the other one is not depending on that thing at all. It has its own behavior, the other quantity has its own behavior. There is no relationship between them, and that's the reason why the coefficient of the subjective correlation of those two quantities comes out to be 0. And if the value of your correlation coefficient R is lying in the mid of your -1 and 0, then you are going to interpret in a way that, for example, if your R is on calculation gives you -0.1. Okay. Yeah, so I've just tried to maintain a line in order to make you clear how to observe or how to determine the degree of correlation after examining or after calculating the value of our coefficient of correlation of the sample data. Okay, so here if you just solve for your R, you just get a certain value and it comes out to be negative.